Hi everyone, welcome back to the workshop. And today we've got the Genmitsu Cubiko desktop CNC on the workbench. We're going to be taking a look at this machine, see what it can do, and try to help you decide if maybe it's something that'll work into your workshop, whether you have limited space or just have small projects to work with. I'm going to run through a number of tests, kind of show you its capabilities, and wrap it up with what I think about this machine. So if that's interesting to you, want to find out more, stay tuned. I'm going to jump right into it. So let's take a look at some of the base features of this machine first, and then we'll jump into our variety of tests. First off, the size. This is a mini desktop CNC machine, so it doesn't take up a whole lot of space. As a matter of fact, it is just under 12 inches wide, and about, well, if you include the front panel here, which is detachable to a point, it's about 12 to 13. It's about 12 inches to the front of the machine, 13 with this little panel, and it is just under about 12 and a half inches tall. So absolutely does not take up much space at all. And it's fairly light. It's pretty easy to pick this up and move it around. It's about, I think they say it's about 17 pounds. So it's got enough weight to hold itself in place, but you're not gonna have any problems moving this machine at all. So something that would be easily, you can put it on a shelf, pull it down when you need it. It's definitely not going to take up a lot of space like some of the bigger machines I have in my shop. It does run on standard AC power, so they do provide you with a power brick that's going to be, you're going to need to order specifically for your locale. So here in the US, we have 120 volt power, but the machine power is only about 125 watts overall, with the spindle being a 75 watt spindle. The nice thing about the spindle is it does have a typical ER11 collet. It does come with an 1/8-inch collet in there. The nice thing about that is you can easily buy replacement spares, or if you want to scale up or down, say you want to get some metric end mills, you can definitely get like a 3mm collet. In the past, I've used these on other machines. I've stepped up to a 1/4-inch collet. You're not going to be using one of those bits on this machine though. But it is nice to have that flexibility in there. As far as control, it does have NEMA 17 stepper motors. The drive on it is 8mm lead screws, and then they have kind of linear rails that most of the axes ride on. The bottom ones are underneath a plate that you can't access very easily, although you can tip the machine up on end, and there's a number of screws on the bottom. You can open that up because you will occasionally need to clean it out from dust, and you do need to service and lubricate, clean those lead screws and such. So, but overall, very simple drive, lightweight drive. Now its working area is about 5.9 inches wide and about 4.3 inches deep. So not overly large. And then you have roughly about a 2¼ inch Z height on there. Now this one does come with a metal spoil board on there, and that is fine, especially if you're doing like PCB boards and such, just engraving. But when you're doing any through cutting, I like to have a kind of a replaceable spoil board, something that's not going to be damaged very easily. So on this one, you'll notice I've added in a plywood kind of replaceable spoil board that does have threaded inserts, or there's screw holes in there that are threaded. So they include a lot of M5 screws that will go into those holes, and then they do provide a couple of aluminum clamps that you can flip upside down or right side up to help with clamping. And these work okay. I have also used double-sided tape method and such, so you got a few different clamping options on there. They also provide you with two basically spanner type wrenches. They have a few different sizes on here. The most important ones you're going to use is the 17mm end and the 13mm end for using the ER11 collet. You do need to hold the spindle in place and then loosen and tighten it. The ER11 collets are kind of a double locking on that. So when you go to tighten it down, you're just going to tighten it down. But when you loosen it, it's going to loosen up. You need to unthread a little bit more and then loosen it again to be able to release your end mill. They do include a small set of bits. There's only 2 different styles in here. They have some 20-degree V bits, as well as the 1/8-inch drill bit. I don't know the specific diameter on the drill. I'd have to mic them, but these would be good for like PCB boards where you need to mill out the copper and then drill out the pinholes. You can also use the V-bits for engraving on acrylics, maybe some soft metals, most woods and such like that. So it is a good starter bit, but I will talk about some other bits that I used throughout as we look at the projects. You also find in there some foam feet that you can put on the bottom. So if you have a lot of vibration and noise, you can add those foam feet. It will help kind of dampen that a little bit, and that's a little bit optional. And then they do also include some replacement limit switches in here. Those limit switches can be a serviceable item, and so they have them on the axes, but they also have one right on the top of the cover plate here. When the cover slides down, it needs to engage that limit switch, and that's kind of a safety feature to kind of protect the machine and the user. And then the other thing they provide is this PCB board probe. What this does is it plugs into the panel in the upper right. The clamp goes on the end mill, and the little kind of spade connector gets bolted onto one of your aluminum clamps that is then needs to be touching the top of the PCB board. That's very useful for setting zero on those really fine materials, because with those you're generally just milling away a very thin layer of copper. This won't work on other items, so like if you're using acrylic or metal, and so you need to use the simple paper method to set your Z for this machine. What that is you'll set your material in place. I usually home my X and Y into wherever, usually the front left corner. And then you want to go into your software or your control panel, set your Z step movement way low, like 0.05 millimeter, and step it down until it just grabs that paper, but isn't digging into the material. You want it to kind of hold the paper without tearing it. That's when I zero my Z's. Bringing you in a little bit closer to this machine. As you can see, I mentioned earlier, we have this clear plastic cover. It does sit down fairly snug, and so I usually just kind of grab it by the lip here, slide it up a bit, and then it'll pop off. There's no real latches to this other than this kind of bottom edge going into this little lip down here. And as I mentioned up top, we do have this limit switch that it does need to engage. And that just helps keep all the dust in there, provides a little extra sound dampening from any cutting that's going on, but the size of this machine and the materials, you're not gonna get a whole lot of extra sound. So as I mentioned earlier, we do have this board on here now. There is this kind of aluminum board on bottom, and then I've added this kind of temporary replaceable spoil board. And then we have all the holes centered for kind of passing through to the threaded holes on the bottom plate, which allows us to clamp items down. And you can probably see a little bit of markings here from some of the projects I did, and that's why we want that spoil board to be basically replaceable, serviceable. As I mentioned, we do have this kind of touch panel, or not touch panel, but control panel in the front. There are some menu options where you can move the machine around, you can probe, you can set things, and there is a little SD card slot on the side, which will allow you to load files that way and basically run this machine offline. So you can use that feature. I'll be honest, I ran it pretty much primarily through the software. You do have multiple options for software on this. The typical candle or universal G-code sender work, similar GRBL type controllers for that. I used the free software from CNC Labs called G-Sender. I've been using that with more of my GRBL software based machines, and I really like that for some of its features of speed and feed overrides, and it's very slick to get set up. So that's my recommendation for this, and just driving it off of a laptop most of the time. They also have the wireless connectivity. Normally you would connect through USB, and those ports are over here on the side right by the power. So I'm driving it just through USB connected to the computer because I like to be able to make those changes. But you can also run it wirelessly through the Genmitsu app and connect to this device and run it that way. But again, my recommendation really is to use the software off of a PC. I'm running it just off of my laptop. So the only other things on this cabinet on the outside is you have your power button. That will power off the machine, power off the motors. And you also have an e-stop button, which will kill all motion and whatnot. This is just kind of a momentary switch, so it basically acts like it tripped a limit switch. The one oddity is, as you've noticed, I've turned off the machine, but if you look here, the control panel is still lit up, and I can go through all the menus right now. It is drawing power off of USB at this point, and so it's just one thing to note. don't get confused. If you're working on your machine and you need to power it off for some reason, you come back and you can go through the buttons, but it's not going to do anything. You got to power it on, and a good sign that it is powered on is that light bar in the back comes up. So the light bar is nice because it does illuminate things, but it is a backlit. The front of it gets a little bit dark, so not a big deal if you're just using it standard, but it did fight me a little bit in videoing some of these things. So that's more of a content creator issue than anything else. It does have decent light. You can see what's going on in there. Spinning it around to the back, there's not a whole lot here. There is a little placard with just some of the basic information of it. They've got the Genmitsu name. They have a model number, serial number, things like that. There is this little rubber port that would be a pass-through maybe for an air assist. They do have a 5-watt laser module you can add to this, so that might be what that's for, but I'm not 100% sure on that. And then some screws that are just part of the assembly process. Nothing much on this side. And then, as I mentioned earlier, you have this base plate. So you can remove this panel in case you need to do any access on the linear rails and cleaning and lubricating the lead screw in there. And also there are some slots on top here where the machine can move forward and back for this gantry. Some dust can get in there, so it's good to get in there and clean it out. They have these rubber kind of grommets. They're not cut out, so I don't know, maybe there's some access ports. They kind of line up with the rails, so you could somewhat oil them, but you wouldn't be able to clean them out. But there are a lot of screws here. You can remove it. This plate is recessed, so just take care when putting it back in that you get that fully seated, and then that should work just fine. Like I said, they do have some foam rubber feet you can stick on here as well to add some dampening to it if you feel that is needed. So let's talk a little bit about the projects I was able to complete with this. Now, you do need to have some software to set up the files for this. I was using Vectric VCarve, and that is very nice software for setting up both 2D as well as 2.5D cuts. If you want to get into more 3D stuff, you need to kind of escalate from there. There are other options such as Carveco is another nice one that they have more of a subscription-based model, so you don't have to pay for the complete software all up front, as well as there are a few free options if you look out there, but some of the more popular ones are going to have a little more advanced features that will let you grow with it down the time. So any of my stuff was created out of VCarve. I will give you, try to give you all the feed rates and things I set up in it to help you out if you're getting started to get in the ballpark what'll work. So let's jump in and look at the projects. So for the first job, went ahead and carved my logo into a piece of plywood. I'll give you a close-up shot of this in a little bit, but it is not the best material to use, but for when just kind of dialing in and figuring out a machine, I've got a lot of this laying around. So we went ahead and set up this job for using one of the included 20-degree V-bits. I used the settings of 20 inches per minute and 0.04 inches, or about 1 millimeter depth, to set up the file for this. It ran pretty well. I had to do just a little bit of sanding on the top, but as you can see in there was some blowing out and chipping out of this material, and that is just something typical with plywood. So it did run okay, but I went ahead and found a piece of hardwood. This is a piece of oak. I had to scale down the logo a little bit, but you can see that kind of held together a lot better. There's still a little bit of cleanup to do in there, and when you get into these finer points, some of the details in the corners are going to be a little bit rounded yet, and that's typical with a CNC machine. It's hard to get any real sharp inside corners. Outside corners are always fine. It can do those, but it did a pretty good job. Now, again, this isn't a fast machine by any means. Each of these, I ran a little conservatively at that 20 inches per minute, just with these engraving bits, and both of these are hardwood-based materials. You're not going to be winning any speed contests with it. And so they took about 20 to 25 minutes to complete these. So the next project I moved on to was a thin piece of acrylic. We went ahead and cut out this circle and had that pocket set in the center. This was all done with a Genmitsu O-flute, so that's a single flute bit. It has an upcut. These are specially made for acrylic and metal, and so these weren't included. I had to purchase this separately, but I will have a link down below where you can find these. So the settings for this, we started with our pocketing pass, and we did 0.06 inches depth total. We did 0.02 inches of a pass depth, And then I actually went a little bit faster on this one. We did 40 inches per minute feed rate and a 40% step over. And so you can kind of see some milling lines in there from that, but it is fairly smooth. And to show a little bit of precision here, went ahead and that's a 40 millimeter pocket for one of these 40 millimeter coins. And it's not moving around. It's kind of the exact fit for this coin. Now it can pop out, but there is no slop really that I can feel side to side. So it's nice to see the precision that it actually got that inside pocket done really nice. Now I did have some tabs on here. So just on the edges of it, you can see the cut is frosted, but fairly clean other than where you come to those tabs. I would need to kind of sand those down, polish those down a bit. By jumping back into some wood project, went ahead and drew up a quick pentagon with a pocket in here. This is some 1/4 inch cedar. So it's a softer material, but still solid wood. We went ahead and used the Downtown Jenny. So this is a down cut spiral bit. It is, this is actually the Downtown Mini Jenny. So it is an 1/8 inch bit. These are made by my friend Cody over at Cadence Manufacturing, and he has a couple of 1/8 inch bits out now in a compression bit and a downcut bit. He's looking to expand his 1/8 inch line with some additional ones as well. So one of my favorite partners to work with on end mills for CNCs. So if you're interested, I'll have a link down to these below. All right, so we took the pocket down about halfway, so it's about 1/8 of an inch out of the whole 1/4 inch material. And we did use an offset climb cut for the interior, so it kind of starts in the middle, works its way out. We did a pass depth of 0.02 inches at 35 inches per minute and a 40% step over for the pocket. And that worked pretty well. There are some lines in there. Now, this is kind of too small for me to have sanded. You can just, if you get it in the light just right, you'll see there are some witness lines, but you can't really feel them. So this is something you'd want to just take a small piece of sandpaper and maybe sand out a little bit to get those visible lines out. But then for the profile, went the full 1/4 inch depth, did a climb cut. And again, we did that kind of 0.02 inch pass. But I ramped the plunges in. So that's where instead of driving straight in, it kind of comes in at an angle. It's a lot easier on the bits as well as the machine. But then I did slow down the cut since it was going to be basically cutting both the inside and the outside at that point. Didn't want to push it too hard. Did it at 25 inches per minute, did pretty well. And then I had some tabs. So I did sand the outside tabs down a little bit, but the rest of it is fairly clean. So the machine seems to be trammed pretty well. I'm not getting a lot of witness lines going down, which is a great sign. We're just kind of getting them in the step over pathing, but just a fun little project made out of cedar. Machine didn't struggle at all with this one and came out pretty well. So after that, I wanted to step it up and do kind of a bit more maximum of what we can get on this. So this is about a 5 inch by 3 inch tray. As I mentioned earlier, the bed size is just under 6 inches by just over 4 inches. So we were really kind of pushing the limits of this. You could go just a bit bigger, but this is about the size of an object you could do on this one. And then this was just about 3/4 of an inch thick. So we started with the pocket, and with this one, I switched over to the IDC Woodcraft downcut bit. This is very similar to the Downtown Jenny that I used, but IDC is another great provider of end mills. And so they have a little wider catalog of options for you, but another good place to look for end mills. So I'll have them linked down below. But we went ahead and started out. The pocket is about 0.325 inches deep. And then again, with the pocket, started at 40 inches per minute. Again, 0.02 inch depth of cut, 40% step over, and ramp those in. And again, used that the profile pathing, so it kind of starts in the middle, works its way out. And then again, I wasn't able to get in there too much to sand. I did a little bit just to kind of show that you can clean them up, but we're not seeing a lot of witness lines there after that sanding, and that came out smooth. The profile cut, that was it wasn't quite 3/4 of an inch, but did get through there. Slowed it down to 30 inches per minute, but I did increase it to 0.025 depth per pass, ramping them in. There was just a little bit of chatter around the transition from end grain to edge grain, and so sanded those out a bit, gave it just a nice clean sanding. But as you can see, Nice little tray. It's maybe about the size of like a soap tray or something, or just a very mini catch-all tray. Now this did take a while. I think overall, this ended up being an hour and a half, hour, 40 minutes. So it's not the fastest way to do it, but it is possible on this machine. You just need to take your time. And so, yeah, if you're looking at this for production and you want to produce this out, sure, you could make a router, just a trim router template for this, cut this out faster, or obviously a bigger CNC machine. That's not what this machine is geared at. This is really geared at a hobbyist wanting to play around. They don't have a lot of space, and you might want to do a bigger project like this. Now, the problem I ran into on this one is by doing all this pocketing, you're creating a lot of chips, and that builds up over time. On my other CNC machines, they're open gantry style. I've got dust collection on them, or I can hit them manually with the shop vac as it's going and keep that clean. I'm not sure how they're going to integrate any dust collection into this with this cover on there. Now, if they've come up with something to bypass this limit switch, you could add, some dust collection onto here somehow. You would have to mount it, or you could manage to hit that. What I did was just pause the job after it did so many passes and the bit was raised. I paused the job, cleaned it out, and let it finish. But dust collection on projects like this are definitely going to be something you're going to have to take in mind and probably plan in some maybe break your job up into so many passes and then have it restart after that, or go in and pause the machine and clean it out mid-job. So a lot of these hobby CNC machines that we test do have some capabilities with non-ferrous metals, so things like aluminum, copper, brass are possible with these. So I didn't set up a big job, but I did do a small pocket. And so you can kind of see in this piece of aluminum there, I've got this small, about 1/4 inch size pocket that I went down just about, I think 1 to 1.5 millimeters. For that, I used, again, I had purchased these end mills. So in here, there was this is an O-flute end mill, again from Genmitsu. This is 1.5 millimeters because I really wanted to take it easy, not have it bite in too hard. Now, ideally, when working with metal, you would have also like an air assist to kind of help keep the bit cool and to make sure that the chips are extracting. That's why the O-flute bits are an upcut, so they pull the chips away, but you still want to have a little bit of a kind of assist with that. Again, that's something that would be kind of a little bit difficult to incorporate to this machine, but they do have that port on the back to maybe bring air in and then mount it. So I think they're maybe planning down the road for some of these accessories to be in there, but we were able to do this. Now I took it very, very slow. I went at 0.01 millimeter past depth, step over of 40%, and I did simply 5 inches per minute, or about 25 millimeters per minute to get this done. It did take a while, but it did cut out. It didn't sound like it was struggling too bad, and overall, it's hard to see. It's hard for me to show this, but it's a smooth top cut, and the bottom, while there are some witness lines from that step over, it is fairly clean on the bottom. Now, one of the things that a lot of people are probably interested in this machine for is for small PCB board milling. So they did include a couple sheets of PCB material. It's copper clad on both sides, and I was able to cut out and pocket out a small PCB circuit. So I reached out to a friend of mine who does do a lot of small electronics projects and said, hey, do you have a legit PCB pattern that I could use? We talked about the size of material I had, and he sent me this one. So I may actually complete this project. It's for a small little light up circuit, but used it for doing some testing and figuring this out. And I did have to run it a couple times to really dial things in. But we started out with, of course, the included 20 millimeter V-bit, as I've shown before. That bit was used to do all the pocketing around. So anywhere we were clearing the copper there, that was just taken down 0.1 millimeters, as I just wanted to really shave off the copper, but not dig into the PCB board too much, because the deeper you go down, the more that V-bit opens up. And these are some kind of fine marks on there. We did that with a 40% step over and real slow again at 5 inches per minute or 25 millimeters a minute speed. So that took some time, and it did leave just a few frayed marks on the copper. So I kind of lightly came back with an X-Acto and just cleaned those up. But then did test these for continuity, and everything did line up. They did have continuity, so the paths were still solid. So the board needs the pinholes drilled out, and so they did include some drill bits, but they were a little bit bigger. This one is 0.9 millimeter. So this was one, I've had it for a while from another manufacturer. You can get these kind of series of PCB boards. They often have these little plastic rings on them as well to help identify them, as well as in some cases they'll identically set them so you can make swapping easier. But we went ahead and we used these to drill it out. Now there's a method you can set up in a lot of software where instead of just driving it down in one pass, you do what's called peck drilling in it. So it'll go down and pull it back out, and it'll just go down deeper till your depth of cut. That makes it a little bit easier on the bit. It helps it to clear out any chips and material. This being a lighter weight machine, I didn't want to push it too hard, or I didn't want to break the bit too bad. So we went down, I think 0.2 millimeter per step, and it didn't take long to get through the boards and made some really clean pass-through holes in there. So that worked pretty well for the drilling of the small pinholes, but then we had to cut through the PCB board. Now these are generally like a fiberglass type material. They're pretty rough. And so it's ideal to use what's called a chip breaker. And so I have a 1/16 inch chip breaker bit. So this has 2 flutes on it, but it also has basically kind of serrations to those flutes and just helps break up the chips. It's a little bit more dusty, but it does a much better job on that fiberglass board. So went ahead and used one of these, did the profile pass, did this at 0.02 inches depth per pass, 10 inches per minute, and I think it took about 3 passes to get through the board, and it came out fairly clean. I didn't want to go too deep, so it did leave a little bit of that copper cladding on the backside, but other than that, the edge of the board, if I can get that to focus on there for you, did come out fairly clean and nice and sharp. Corners are nice and sharp. So overall, it did a nice job on this. So for circuit boards, PCB boards like this actually might be a really nice machine for that. It's going to have a big enough work area for that, but it's not going to be too in the way. It's got the dust cover because this fiberglass stuff definitely is not something you want to be inhaling. So it's going to kind of contain it to inside the machine, and then you can use your shop vac or whatnot to clean it up afterwards. So, and finally, to show some of the detail it can do, went ahead and did a 3D carve. So this is a piece of maple that we have kind of these recessed dice in here. And so that came out pretty well. And I used a couple different bits on this one. So I started out again with one of my non-standard bits. This is a 3/32 inch 2 flute upcut bit. Use this as a clearing pass. I wanted to find the balance between, I wanted to go a little smaller than 1/8 inch because that gets into more detail, and the more material that you can kind of do in your roughing pass to clear out of the way, the less strain it is on your ball nose detail bit, and the faster you can run that one because it'll have less material to remove. So went ahead and used one of these to do the initial clearing pass. And it looks really ugly after that first step, but it's just pocketing out areas, removing the bulk of the waste you don't need. And then went ahead and used, this is from Spee Tools. This is a tapered ball nose bit, and I'll give you a little closer view of that here. So it's got 2 flutes and it tapers down, and then it has just a radius at the bottom. So this one is an 1/8 inch diameter. It has about a 4.2 degree angle to it, so pretty fine taper on it, and then a 0.5 millimeter radius on the bottom. They actually have one that's slightly more detailed, but I was concerned about using that. The smaller the radius you get, the more detail you can get out of it, but we also step it down to a pretty small step over, so the longer it's going to take. What I actually did with this one is I ran 2 passes. So I ran it at a 45 degree pass in one direction, and I used a pretty heavy step over. I left it at 40% at that first pass, just to, again, kind of get a lot of that down and get more of the waste out. But then I came back in the other direction, 45, basically 90 degrees to that, which helps remove some of the tooling. And in that one, I used a 5% step over, and that's the one that took a long time. But we ran both of those, and I think I stepped those. I started at 40 inches per minute, but the nice thing about this G-Center from CNC Labs, you can adjust your feed rate. I stepped it up to about 50, maybe 55 inches per minute, especially on that last pass, because it wasn't clearing a lot of material, so you're not straining it as much. But this is straight off there. I have done 0 sanding on here. And so hopefully that detail is coming through on there. It's very clean as well. You don't see a lot of lines, and that's where doing the basically a crosshatch kind of mill on here. Now again, this did take a while. I think it was about an hour and 20 minutes to complete all of it. The first couple passes, you know, the first pocketing one was I think 6 or 7 minutes. The second one was about 9 to 12, but the last one was about an hour 20 to complete the carve. But it did come out very nice, get some nice detail in here. This is recessed into there. You could also clear it out so that pops out of the wood. There's just some different options in there on how to do these. But kind of a cool thing that, like many CNC machines, you can definitely get some nice 3D effects carved into them. Of course, there's always things that I think could be improved on machines based on my use of them. So let's talk a little bit about some of these. One of the big ones, and I mentioned the enclosure is nice. However, that does limit your dust control options. So I know they list one as an accessory. I'm not sure how that really works with this one. So I hope that's something they're considering. Maybe being a bypass for that limit switch, but dust control while it's running, if you're doing things like these wood projects, is going to be something you're going to need to take into consideration. Now, the other thing I noticed is on this front panel, it can power up just off of USB power. Again, that was a little disturbing the one time I was moving some things around, forgot that I had turned the machine off, and I'm trying to figure out why am I getting this error? Why is the machine not functioning? I'd love to see this panel not boot up, even if it's powered in via USB. But just be aware of that. If you're working with the machine, it's not responding, double check that the machine is actually fully powered on before you start diving down into the error codes and such. Finally, they do include these metal clamps I mentioned earlier. They do work well and they're great, especially for like PCB boards and getting that auto probe. But when working with other items, and especially as a first-time CNC machine user, I'd like to see a plastic option as well. So, you know, that might be something that recreating these in a 3D printed method would be good. As well as the spoil board. The stock spoil board is metal. Again, that's great for things like, you know, just engraving stuff. But if you are doing through cuts, and you don't want to damage that spoil board, that metal spoil board, you're going to need to put some sort of spacer in there, or some sacrificial board. So, like I said, I basically used the lasers, cut out one that fit right on there, and it's protecting that metal board from getting cut in. And also your bits, when they pass through, you want it in a material they can cleanly cut through, as opposed to metal. If you're using a higher speed rate and you dig into that metal, it's probably going to break your bit. So just a few things that I think could be improved about this machine. All right, so that's going to wrap it up for this overview of the Genmitsu Cubiko. I want to thank them for sending this out for me to check out and share my thoughts and my test results with it for you. So this machine is available for $350 on their website at the time of this video. So I will have a link down below if you are interested in this. It is an affiliate link that does help them know that my information was useful for you, and does give me a little bit of a kickback that goes towards all the materials you see here, trying to make sure that I can run these tests and help inform your decision. But as always, just happy to give you that information, and no pressure to use my links, but I do appreciate it when you do. If you have any questions or comments about this, I would love for that interaction down below. Interaction like that does help YouTube send this video out to others. So if you found this useful, hit me up with a comment, hit that like button. And if you have questions, I'll try to get back to you in a timely manner. And we will see if we can help you out more with questions about this unit. If you're interested in more about what I do on my channel, I do a variety of product reviews like this, project videos. I go more in depth on how to make some of these, as well as with lasers, some 3D printing, and other just general making machines, small business machines for kind of creating and customizing products. And so I would love your subscription and check out some of my other videos, as well as I do a Sunday night live stream with my friend David over at the Clack Shack, and he actually has a video about this. He had the prototype one out. So definitely check us out on Sunday nights, 7 p.m. Central Time. We get on there for a couple hours. We talk about new things such as this machine. I'll probably be talking a little bit about it this week, as well as answer any of your questions live. Otherwise, thank you for checking this out. I hope you found it useful. Hopefully I gave you some good information. Thanks again for watching. Glad to see you here. Hope to see you in the future. But in the meantime, hope you get into your workshop and make something too. We'll catch you next time.